us who you are, where you're from, and how you ended up doing postdoctoral research for Sydney Uni.
Okay. So I'm Ed Jones. I'm a researcher at Sydney University. I grew up in the south coast and Riverina regions of New South Wales. My passion for agriculture came from working on my grandparents' farm, which I used to do every school holidays growing up.
Okay, cool. So this research that you're doing for the area of your research, what is it?
So I work in digital soil mapping and spectroscopy at the moment with a focus on precision agriculture.
So digital soil mapping, can you explain that further?
I would say it's about turning a few points of soil information into a map of soil information.
And with the end goal of using that for what? What would be the end outcome of using that for a farmer?
Resource management, I would say. For me, the focus is mapping soil properties, analysing how they affect yield, and then seeing whether are they soil properties that we can change, and if we change them, would it be worth doing for the yield increase?
Ed, what is the soil spectroscopy?
So the basics of spectroscopy, we have a special light that we shine on the sample, on the soil. That light interacts with the sample, and then we read the light that comes back from that across the whole spectrum, so the visible and the near infrared. And from that we build calibrations to work out soil properties such as clay content, pH, organic matter.
And so that is very exciting, because what will that lead to for on the farm? I understand it at research, but will it almost be like a soil test in your pocket type thing potentially?
My end goal from this research is to build a digital soil map without sending a single sample to the lab. And the benefit of using spectroscopy is it's cheap and quick to do, so you can get a much better spatial coverage of sample locations.
Okay, so the idea is that you just pull some cores and literally soil test them in the paddock.
In the paddock, and we're also developing a penetrometer that you can push into the ground.
So why is a penetrometer important? What's a penetrometer do first? Let's explain that.
So the penetrometer is just a long pole that we'll push into the ground, and we'll get our spectroscopy reading as we push that into the ground.
So that's measuring. Sorry.
Near infrared spectroscopy.
Yeah. So that's so the penetrometer is measuring the force that gets pushed into the ground with.
Yes, and it'll be measuring the clay content, organic matter, moisture content every centimetre as we push it into the ground.
Cool. So that's something that you're designing here at Sydney Uni, is it?
Designing here at Sydney Uni in collaboration with colleagues from Texas A&M and University of Nebraska.
So it's an international project.
Yeah.
Wow, cool. What benefits do you see spinning off that for Australian farmers?
Just mapping the potential of the soil resource on a much finer scale.
How accurate is those soil readings against the traditional soil lab wet chemistry approach that we've done in the past historically?
So at the moment, when we analyse the samples in the laboratory, the accuracy is comparable to what you get when you send it to the wet chemical lab.
Yep.
Out in the field, we're still overcoming some issues such as variable soil moisture is a big one to overcome, and also surface preparation. So in the lab, we grind it to 2 millimetres and then scan that. Whereas when you're doing it out in the field, you've got to compensate for smearing of the surface.
Cool. So what soil parameters can you measure all the soil parameters at the moment, or like the macros and micros, can you measure them all accurate at the minute?
No, and don't listen to anyone who tells you that they can.
Why is that?
We get good calibrations with properties that are in equilibrium with the solid phase of the soil, so driven by the soil minerals such as clay content, cation exchange capacity, pH, properties like that, which can tell you a lot about what's going on in the soil. And if you put nitrogen on, what's it going to do? But we can't measure nitrogen directly,
Okay.
for example, with these devices. And yeah, don't listen to anyone who tells you that again.
So you can effectively work out your bucket.
The bucket's one thing, yeah, that we can work out.
Yeah, so your drained upper and lower limits and all that stuff. Is there any area or research where this will probably be able to do nitrogen? Because I mean, that's a massive input variable for lots of farmers, especially in a year like this.
What, directly on the soil?
Yeah.
I mean, so on leaf analysis, it's fine.
So
People get good calibrations doing it on leaf analysis.
yeah, but that still doesn't give you the soil.
But not soil, no. We're working on a couple of different methods that I won't talk about, but
It's
Do
for
get that.
stuff to come.
Stuff to come, yeah.
Cool. How far away do you reckon that is?
someone's in the lab doing it now, so we'll see.
Cool. Exciting times. Exciting times. So, what's your other roles here at Sydney Uni? You do a bit of teaching as well, by the sound of it?
Do a bit of teaching. We have a lot of international students who come over and do internships. So we teach undergrad courses, master's level as well. I do a lot of teaching with that. Going on the field trips, making maps in preparation for that. And then I've got 3 international students at the moment who come over for 2-month internships, and we set them up with some lab work or some computer work to do.
Or better question is, would you do it again?
Would I do it again? I'd do it again, certainly. But
Why would you do it again?
it's a great chance to apply subject areas that I really like: mathematics, science, agriculture. A big combination of that. There's a lot of amazing science that's happening, but that always brings about more questions. So there's a lot more to do.
Cool. So that's a growth area.
Growth, yes.